Welcome to Machine Learning Frontiers, Breakthroughs from cs.LG on July 11, 2025. This deep dive explores 51 influential papers that are shaping the future of artificial intelligence. Key themes include interpretability, efficiency, quantum AI, and more, with special focus on a standout interpretability paper by Sutter and colleagues. Curated by AI Frontiers, this session is designed for both researchers and AI enthusiasts. Did you know that today's most advanced AI models can process entire books in a single pass? Thanks to remarkable efficiency gains, artificial intelligence now operates on smartphones, making sophisticated analysis available anywhere. Quantum classical hybrid systems are also unlocking new scientific possibilities. These innovations fuel tomorrow's breakthroughs, and the research driving them is being published right now. In this episode, we examine the mechanisms behind these rapid advances. Machine learning is now a foundation for transformation across multiple industries. On July 11, 2025, 51 new cs.LG papers showcased cutting-edge discoveries and ideas. This exploration will unravel the motivations, technical breakthroughs, and persistent challenges found within these works. From theoretical advancements to real-world applications, the expanding role of AI is more evident than ever. Join this journey to understand the latest in artificial intelligence innovation. The cs.LG category, representing computer science, learning, is the vibrant hub for machine learning research on the arXiv preprint server. Imagine this as the innovation district within a bustling city, where researchers use statistics, code, and mathematics as their building materials. Machine learning equips computers to learn from experience, rather than following predefined rules. As society generates vast amounts of data, extracting meaningful insights has become essential, positioning cs.LG as a central pillar in both computer science and broader societal progress. Interpretability and robustness form the first major theme in current machine learning research. Interpretable AI is akin to exploring the inner rooms of a neural network mansion, aiming to understand how decisions are made. The work by Sutter and colleagues questions whether causal abstraction alone suffices for true understanding. Robustness ensures that AI decisions remain stable under varied conditions. In this domain, researchers act as both architects and detectives, striving for mechanistic interpretability, that is, clear explanations of how models function internally. Efficiency and scalability represent the next frontier, often visualized as transforming freight train scale models into Swiss Army knife AI tools. Large models are powerful, but resource-intensive. The Wursa mechanism, introduced by Dentamaro and colleagues, drastically reduces computational demands for processing long sequences. Optimizing model training for mobile and low-power devices is now a key focus. Spectral attention techniques, specifically Wursa, enable efficient sequence processing, allowing more to be achieved with fewer resources. Quantum and distributed learning are accelerating innovation beyond classical limits. Quantum classical hybrid models, likened to maglev trains in research, are being developed, as seen in Marcandelli et al. PHQFNO approach that integrates quantum and classical methods. Federated learning enables collaborative artificial intelligence without centralizing sensitive data. Algorithms such as SFED-KD and greedy lore further enhance privacy and efficiency in distributed settings. The landscape of distributed AI resembles a complex adaptive railway network, enabling both collaboration and innovation. Several headline findings emerge from these 51 papers. Sutter et al. Demonstrate that standard interpretability methods may not accurately decode neural networks. Dentamaro et al.'s Wursa mechanism democratizes access to long-sequence AI processing. The greedy lore algorithm achieves smart compression in distributed learning. Marcandelli et al. Show that hybrid quantum models deliver tangible scientific gains. Advances in reinforcement learning are producing safer, more risk-aware AI agents, suitable for deployment in high-stakes environments. The featured paper of the day, The Non-Linear Representation Dilemma by Sutter and colleagues, probes the core of neural network interpretability. The prevailing standard, causal abstraction via linear mapping, has been assumed to yield trustworthy explanations. However, the authors question the validity of this assumption when the linearity constraint is removed, introducing surprising implications for the field. Their motivation lies in ensuring that AI explanations remain reliable, particularly for critical applications. The paper uses the metaphor of a Rube Goldberg machine to illustrate the convoluted nature of some explanatory frameworks. Sutter et al. Present both theoretical and experimental findings. They provide a proof that nonlinear mappings can always be constructed to explain a model's outputs, regardless of actual learning. In experiments involving language models on indirect object identification tasks, nonlinear explanation maps achieved perfect performance even when the underlying models had failed at the task. These results challenge existing notions of what constitutes a real explanation, prompting a re-evaluation of current interpretability standards. The research process was characterized by intense discussions and a strong drive for transparency. The implications of Sutter et al.'s findings are significant. Their work calls for more principled and robust constraints in the development of AI explanations. As a result, the research community is rethinking benchmarks for mechanistic interpretability. The stakes are high, as trust in AI is critical for applications in self-driving vehicles, healthcare, and finance. This paper has also prompted introspection among researchers, encouraging them to question their own assumptions. It is already influencing the direction of new research efforts within the interpretability domain. The future of AI innovation can be envisioned as a dynamic river, with diverse tributaries merging into a powerful current. Upcoming models are expected to be larger, more efficient, and sustainable, capable of running on a range of devices from supercomputers to mobile phones. Interpretability is forecasted to become an essential feature rather than an optional one. The fusion of quantum and classical computing promises to unlock new scientific frontiers. The ongoing convergence of multiple research streams will continue to shape the trajectory of artificial intelligence. In conclusion, artificial intelligence is evolving rapidly, from the enigmatic mansions of neural network interpretability to the high-speed express lines of computational efficiency and quantum classical integration. The research released on July 11, 2025, offers a vivid snapshot of creativity and rigor in the cs.LG community. The challenges posed by Sutter et al. Invite continuous questioning of how AI is explained and understood. Engagement from the broader community, through exploration, discussion, and knowledge sharing, remains vital for progress. Stay curious and continue this journey to the frontiers of AI. This presentation was synthesized through a collaborative process involving advanced AI tools and human expertise. OpenAI's GPT-4.1 was utilized for in-depth analysis and summarization. DeepGram TTS provided the voice narration, and Grok was used for visual generation. Content was reviewed by a human expert to ensure clarity and accuracy, although some oversights may remain. Listeners are encouraged to consult the original reference papers, cited as first author et al. For further details. Thank you for joining AI Frontiers. Like what you heard? Subscribe for more deep dives into artificial intelligence breakthroughs. This channel delivers the latest discoveries and expert synthesis, accessible to everyone. Join the AI Frontiers community to explore, question, and discuss the future of technology. Keep pushing the boundaries of AI together. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.